In this video, we are going to discuss how to find the shortest distance from a point to a line. Shortest distance from a point to a line. Let's say I have a line here, call it line L, and this line L passes through point A, and the direction vector of this line L is B. Let's say I have a point P away from the line. Point P is here. So if we want to find the shortest distance of point P to line L, the shortest distance must represent a line drawn from P to line L that is perpendicular to line L. So this is the shortest distance. Shortest distance from P to line L. If it is not perpendicular to the line L, if the dotted line is not perpendicular to the line L, let's say the line is this, from P to line L, this is not the shortest distance. Similarly, on the other side of it, so this is not the shortest distance. So the shortest distance from a point to a line L, the line that we try to draw, the dotted line that we try to draw to the line L, must be perpendicular to the line L. And this point is important here. Let's say I call it R, and this is called the foot of perpendicular. And point R here lies on the line L. That means R is a point on line L. But we don't know what is the coordinates of point R here. So how do we find the distance here? If you remember, we discussed about dot product. So I can actually put a vector PR, P to R, a vector from P to R. Because the line PR is perpendicular to line L, therefore PR, vector of PR, dot the direction of line L, which is B. So PR dot B must be 0, because PR, the vector of PR, is perpendicular to the B. And we use this equation to start to find lambda. After knowing lambda, we put it back into PR, and then we find the magnitude of PR. Then we will be able to find the shortest distance of point P to line L. So if you want to find PR, the vector of PR, so we have one video before, how do we find a vector between 2 points? So we can make use of position vector of R minus the position vector of P. So PR is equals to OR minus OP. So OP may be given to us, but point R we don't know. But because point R lies on the line L, therefore we can represent OR using the general point of the line out. That means we can rewrite the equation of line out in the general position, so we call that as point R. If you can recall that if we know lambda, if we know the value of lambda, then we will know certain point on the line. So I discussed in the previous video that if lambda is 0, so it is actually referred to point A. So since we don't know R, but R is the foot of the perpendicular and R lies on the line L, so we use the general point of line L as the OR. And from here you will get the column vector which is in lambda. So in the next video, I will show you an example. How do we find the shortest distance from a point to a line? See you there.